Okay, let's talk about optimization. So let's couch it in the category of analytics that it's in. We've done descriptive analytics largely to this point. We haven't done a ton of predictive, and optimization falls under prescriptive. Um, so prescriptive is we've diagnosed it and we know how we need to solve it. We just don't know how to solve it. In other words, we know what the problem is, but we need a prescription. And so optimization is we're going to use solver. That's basically what we're doing. And you'll see that solver, we define the desired outcome. Usually it's maximizing or minimizing a value by manipulating the input values. So let's step through this. So just keep in mind optimization is kind of like the epitome of prescriptive analytics. So one thing you'll want to look at is if you go to Blackboard under Chapter 3 Types of Data Analysis, I am using a set of slides out there right here under optimization. So I've got the slides, and then we may use this quadratic example just so you can understand boundaries when we get there. So the other thing that I'd encourage you to do, and it's not actually chapter 2 that corresponds to optimization. If you click on this DataSmart link, this is a book that's available through the library. So you can get an electronic copy. You'll have to sign into your account. I'm going to click on that. This is like one of the coolest books that I've ever found to show you how to use Excel in really advanced ways. So we'll go ahead and read it online. You're going to be interested in chapter 4. So when we get here, we'll close our research assistant. You're going to be reading chapter 2 for the cluster project. So if you want to get a jump start on that, you can. But chapter 4 is the optimization, and he uses solver to do it. And so this first problem is going to come from chapter 4. So you can use that as a reference. And you'll see kind of the scenario here, which we're going to go through. So just wanted to point that out. I've got it in the slides. So let's get started here. So here's the scenario from the book. Essentially, you're like World War II undercover, and your day job is milking cows and making butter. You can read through this. Your night job is building and selling machine guns to the French resistance. Um, it's complicated, but you're trying to maximize your profit. The objective is you want to maximize your profit, and you get $195 in revenue for every machine gun you sell to your contact. You get $150 for every ton of butter you sell in the market. And you need to bring in as much revenue as you can each month. I guess we're maximizing revenue here, although we should be maximizing profit. And you got to figure out what mix of guns and tons of butter you need to produce. The constraints deal with our budget. So it costs $100 to produce a ton of butter, $150 to produce a machine gun, and you have a budget of $1,800 a month. That's your monetary constraint. But then you have to store this stuff in your cellar, which is 21 cubic meters. Guns take up half a cubic meter, and a ton of butter takes up 1.5 cubic meters. So at this point, it's really appropriate to just pause and ponder, what does 1.5 cubic meters of butter look like? That's a lot of butter. Think about what you could do with that. Okay, and once you've paused and thought of that, it's time to move on. So these are the steps to solving optimization problems. And if you follow these steps, hopefully it'll be like building a word problem that you have such fond memories of from elementary school and middle school. The first thing you want to do is identify the information given. Essentially, just writing down what you already know. You're capturing it on the spreadsheet. Then you need to identify what your inputs are. And you can choose some arbitrary value for them. You just have to set them to something. Set 0 if you can't think of anything else. But your inputs are your levers that you can pull and push and move to actually arrive at your output, which is the thing you want to optimize. You can identify your inputs because you have control over them. And then your target answer is that output. What do you want to optimize? And in this class, you're almost always going to be minimizing or maximizing a target variable. Then you have to identify your constraint, because there's some problems that if you don't constrain them, you could never reach the maximum output variable, because it would be just keep going up and up and up and up, and you could keep manipulating your inputs and driving the output variable up and up and up, and there's no bound. So like our seller and our budget are our constraints. And then you want to basically connect the dots from your output, your target answer, to the input, or vice versa, your inputs to build up to your target answer. And that's just cell referencing, creating intermediate calculations. If you can break it down, sometimes it's easier to arrive there. So then you're going to eventually build up to creating a target formula, which is your target answer. And then you're going to let solver do the work. This is an excellent example of computational intelligence. Computational intelligence is, hey, the computer does things better than I do in some ways, and I do things better than the computer, but I have to learn how to communicate what I want from the computer. And so if you set the problem up right, you can turn Excel's solver loose and have it do all the grunt work. So if you can get steps 2 through 4 correct, it's going to make your life a lot easier. So let's just step through what this looks like. Most of these problems that you're going to do for the homework, I've given you a template like this. It doesn't always look like this, depends on the problem. But let's just start with the given information. If you remember from our problem, we enter in here the price of a ton of butter that we can sell it for is $150. We can sell a gun for $195. The cost of a ton of butter to make is $100. The cost to make a gun is $150. And the size of a ton of butter, again, imagine 1.5 cubic, that's 4.5 feet cube of butter. That's like not quite as tall as me. Just, it's amazing. Think about it. I wonder if it's salted. But then you have the size of a 0.5 cubic meter of space that a gun takes up. So we've recorded those. That's easy. We just pulled those straight from the problem. And now let's go in and identify our inputs. What do we have control over? Well, we can control the number of guns we make or the tons of butter that we make. That's all we have. And you can set these to any value that you want. Probably something reasonable. Set them to 0 if you can't think of anything else. Then we're going to identify our target variable, which is actually profit. We want to maximize our profit. Okay. And then we're going to identify our constraints. And the constraints are kind of like givens. We're just going to list them here. Our seller capacity, we're constrained by that. So our total volume of guns and butter can't be greater than 21 cubic meters. And our total cost every month can't be greater than $1,800. So now this is where we have to start doing the intermediate calculations. But before that, let's take just a quick intermission and talk about constraints. If we're actually to draw these, where we put the number of guns on the y-axis and the number of butter on the x-axis, and I pulled this from DataSmart, you can go read about it. We could actually make 0 guns, and we could, I think that's 18 tons of butter. That's probably either limited by our budget or it's limited by our seller. If we produce no butter, we could make 12 guns. And I believe that's, because they're smaller, I believe that's limited by our budget. And so those two extremes, and you can see the ideal would be as we push this budget constraint out. Oh, sorry, this is our budget constraint. As we push it out further, hold on, let's go look at seller constraint. So if we were just constrained by our seller, we would have zero butter on one end and like 42 guns that we could make. And so I said this wrong. I was talking about budget and seller constraints too soon. The first one was just budget constraint. The second one is seller constraint. So if we're just constrained by our seller and we produce all butter, we could only produce 14 tons of butter. Whereas if we were constrained just by our budget, we could produce 18 tons of butter. So you can see what we're interested in. Ultimately, to maximize our profit, we have to look at the intersection of these two. And right there, that's going to be the furthest from 0, 0. Right there is going to be our maximize point. So the idea is we just want to follow this outer constraint edge, and we want to get it just as far from the origin as possible, and that would be our maximize point. That's kind of what's going on conceptually, but we can let Solver kind of plug all these in. So then we do the intermediate calculated fields. Well, make it easy. Can we figure out the butter volume? The total butter volume? Absolutely. It's going to be the tons of butter we decide to make times the size of 1 cubic meter of, the size of 1 ton of butter. And so it's 10 times 1.5 gives us 15. And these are just starting values here. And we're going to go through this again. Gun volume, same thing. It's the size that one gun takes up times the number of guns that we decide to make. Total volume, add those two up. Butter cost, it's the price to produce 1 ton of butter times the number of tons we make, so on and so forth. Add up the total cost. And then what's the revenue that we're going to get? Our revenue is just going to be the price of butter times the total tons of butter we make. Add up the total costs. And then we just have in here, can we calculate profit, which is just going to be our total revenue minus our total costs. And that's our target variable. And that's what we're going to tell Excel to maximize by manipulating our two input variables. So Excel literally is going to just be plugging random numbers into these two cells, monitoring this until it finds the maximum. So with that, I'm going to pop out of here and let's go open up our... We've got our given information here. And we're just going to start bringing it in. So I'm going to move this aside so you can see what I'm doing here. I'm just going to transfer all of this over. We use this sheet here, but know that all this came from the word problem. Okay, so we'll take our completed sheet. I'm just going to transfer this over. So butter price per ton, $150. Gun price was $195. Butter cost per ton is $100. Gun cost is $150. Butter size, I could have called this volume. It's cubic meters per ton. Gun size. Let's see, I'm just entering this in. I can decide how many guns I'm going to make. I'm just going to say, let's start by making 1. I'm going to decide how many tons of butter. And let's say we're going to make 2 tons of butter. Those obviously aren't our optimized values, but it's a starting point. So then I'm just going to say, well, I ultimately want to calculate the total profit because that's what I'm going to maximize. I'm not going to stick the equation in here because I'm going to build up from the equation by starting by referencing these two cells and creating intermediate calculated fields. So this is kind of like information modeling. So butter volume. So it's going to be the tons of butter to make times the size of one ton of butter. Gun volume is simply going to be the number of guns to make times the size of one gun. And then we're going to have the total volume, just going to be the two of those added together. And then we're going to have the butter cost, which is just going to be the number of tons of butter times the cost to make 1 ton of butter. This is going to get kind of repetitive. We're going to have the gun cost. It's going to be the number of guns we decide to make times the cost per gun. Just checking these. Okay. Then our total cost, we can figure that out by just adding those two together. Yeah, you could put these into more complicated formulas and can combine some of these steps. That actually, I multiplied that. Better watch out for that. Okay, and now we're going to get our butter revenue. It's going to be tons of butter we make times the price we can sell a ton of butter for. Gun revenue is going to be the number of guns to make times the price we can sell each gun. Total revenue is going to be the sum of those two. And now we can get total profit by taking our total revenue and subtracting out our total cost. And this is the value that we want to maximize. Now, it's really important before you ever go to Solver, there has to be a referencing link between these two, between the inputs and the output. If there isn't, Solver won't do you any good because I need to be able to modify this. So if I change that to 3, you see my output change. If I change this to 1, you see my output change. So it needs to have that connection because, again, Solver is literally just going to be plugging random numbers in here. It's going to happen so fast that you won't see it. It's not going to bother updating the user interface, but it's going to plug them in there until it maximizes this. So then once we got this, we can go to Data and Solver. And if you don't have Solver on there, you need to go to File, Options, Add-ins, Excel add-ins down here, go, and you'll click on Solver add-in. So once you do, you'll have this solver here. And now let's go through these parameters. It says set objective. The objective is to maximize, see this? So set objective cell, our objective cell is that, and we want to maximize it. So we're saying maximize that cell, see it says E2, by changing, and these are our input cells, and so I'm just going to drag out over those two, changing our two inputs, B9 and B10. So again, it's going to plug in numbers here and change this until it maximizes it. But we have some constraints. And so I could go ahead and solve this. See, it's going to churn. And it gives me some errors. That's okay. We're going to come back. We'll hit cancel. But let's add our constraints here just so they're on our page. We could actually hard code these in to our constraints in the solver. But just so we're keeping track of things. Okay, so our seller is only 21 cubic meters big. Our budget per month is $1,800. Now let's go back to Solver. And we're going to add in our constraints. Notice it kept all our existing inputs. So we're going to add a constraint. Our first constraint is our total volume. This one right there has to be less than or equal to our seller size. So I'm just saying that this value, total volume, has to be less than 21. And I could type in 21 right there if I wanted to, but I got it on my spreadsheet. Then I'm going to click add because I need another constraint. And we also can't exceed our budget. So our total cost has to be less than or equal to our total budget for the month. Oops, let's do this right. Total cost, and then I got to click over here. Has to be less than our total budget. And again, you could, inside the constraint, you could put $1,800 if you wanted to. Now we click OK. We see we've got those two constraints. And now we solve it, and it says, solver found a solution. We're like, awesome. So we keep the solver solution. We click OK. And you can see it's basically saying, hey, you're going to want to make a part of a machine gun and a portion of a ton of butter, which we could do butter that way, right? But it's hard to make a part of a machine gun. So we're like, well, there's got to be one more constraint. We have to constrain these to be whole numbers. Ready? So we're going to go back to solver. We're going to add another constraint. And on this pull down here, we're just going, well, we're going to select these two inputs. So B9 and B10, I'm selecting those. And on this pull down, I don't want them to be less than or greater than or anything. I just want them to be integers. And that int right there, I'm going to click OK. It adds it, and now I solve again. It's like solver found a solution. We're like, woohoo! And it's telling us that we can expect to profit $785 if we make 3 guns and 13 tons of butter. And that's our maximized profit. So solver just maximized this for us. Okay, so that's how you run solver, and that's how you set up a problem for solver. So what I want to do now is, I think your homework then is going to be these problems right here, and they're all right here. And you really should watch this video about the Knights that say knee. I wanted to do this for a Becker course I did, but copyright issues. But anyway, you can build stuff that says out of shrubbery, which is really important. And so you're gonna have to think about how to set these up, and I'd encourage you to post problems to solver. But let's try like this maximizing shirt production. So when we did the seller problem, the guns and butter problem, we had defined constraints. Okay, but sometimes there's natural constraints, and I want to show you what I mean by that. So I believe this, give me just a second, this quadratic. Sometimes if we just kind of graph this, so I think this is one of the problems. Like in this case, if this was like our pricing formula, we have a natural minimum. And so we may not have any hard-coded constraints because there's a natural minimum. And that's kind of what's going to happen with this shirt problem. So let me pull this up so I can walk us through it. 1 second. All right. So let's talk about the shirt problem here. So we have this maximizing shirt production and profit. So we manufacture shirts, determines that our cost will be $500 for overhead plus $900 or plus $9 for each shirt made. Her accountant has estimated that her selling price P should be determined by this equation, 30 minus 0.2 times the square root of x, where x is the number of shirts sold. So let's come over here. Let's capture our given information. Okay, so our overhead cost, we already said, is going to be $500. And then our variable cost is going to be $9 per shirt. But what we'd really like to do is we'd want to figure out how many shirts we need to produce and the price per shirt, and we could just give it a number. Like, let's just say we're going to start with 1,000. That's the sell we're going to change. But then our sales price is dependent upon our price on the number of shirts we produce. So like we start flooding the market and people don't want to buy them anymore, so the price goes down. Okay, so we're going to implement this equation right here. So we're going to say 30 minus 0.2 times the square root of the number of shirts we're going to produce. And so if you actually graph this, you would see that there's a natural maximum. As we start selling more and more shirts, our price goes down. So let's say we sell 500. Watch, our price goes up. If we sell 50,000, our price becomes negative. So there's a natural ceiling to it. And you could graph that out if you wanted to. Okay, so let's start at 1,500. And then let's figure out what our output is. Our output is we want to maximize our profit. Okay, so we'll build up to that equation. So how do we do that? Well, can we calculate our total revenue? Yes, because we can say we're going to take that price times the number of shirts we make. It's our total revenue. And can we calculate our total cost? Yep, we can take the number of shirts we produce times 9. Then we better put this in parentheses. So we multiply that first, and then we add on our overhead costs. That's our total costs. So can we calculate our profit from that? Sure can. We're going to take our revenue minus our costs. And notice here, I put this here just to kind of trick you, because there is no constraint. There's a natural constraint like we shown up here, that as we change this to like 150,000, we go way negative, and eventually our profit probably goes negative. I won't expand that to see. See, we start getting negative profit, so we're obviously not going to do that, so it's going to naturally maximize. So let's set it down something in range. And now we can just go run solver. So how does this work? We say we want to maximize our profit. Click maximize by changing the number of shirts to produce. And we have no constraints, so we click solve. It found an answer, and it says you should produce roughly 4,900 shirts, and you'll make that much profit. So you can see the answers here. How many shirts should we produce? 4,900. At what price should the shirts be sold? They should be sold at $16 each. And what's our resulting profit? $33,800. So that is a rundown of optimization and how to use Solver. Have fun with the homework.